Let us study Ohm's law. German physicist Georg Simon Ohm, in 1827, stated that the electric current flowing through a metallic wire is directly proportional to the potential difference, V, across its sense, provided its temperature remains the same. This law is called Ohm's law. We shall verify the law with the help of this activity. Take a nichrome wire of about 0.5 meters, a millameter, a voltmeter, a switch, and 4 cells of 1.5 volts each. Connect the nichrome wire only one cell, a millameter, and a voltmeter, as shown in the circuit. Pass the current through the circuit. Note down the current passing through the conductor. Here it is 120 milliamperes, and voltage across the nichrome wire is 0.3 volts. Now use 2 cells instead of 1 and note down the millameter and voltmeter readings. The current through the wire is 200 milliamperes, and the potential difference across it is 0.5 volts. Similarly, find the current and potential difference, V, by connecting 3 cells, and then by connecting 4 cells in the circuit. The observation table shows the current and voltage values obtained by changing the number of cells. We know 1 ampere is equal to 1000 milliamperes. Therefore, the values of current in amperes will be as shown here. From these observations, you can easily make out that, with the increase in number of cells, the V and I values also increase. We find that ratio of voltage to current is constant for all the readings. It is 2.5 volts per ampere. Hence, we understand that voltage is directly proportional to current, and the Ohm's law is verified. The VI graph is a straight line passing through the origin. Now voltage is directly proportional to current. Voltage upon current is equal to constant. This constant is R, where R is called resistance of the metallic wire at a given temperature. Resistance is the property of a conductor to resist the flow of charges through it. Its SI unit is ohm, where 1 ohm is equal to 1 volt upon 1 ampere.